So hello Arya, so we're gonna continue from our last lesson where we got the ball to move in a in a curve path under the influence
And it
of
falls
gravity.
down.
Yeah, so now we'll continue from there. And what is the problem we faced last time?
Is
Is
our
that
code is getting too long?
no, these calculations
Yeah.
are getting too complicated, right? We
Yeah.
want them to simplify this calculation. So to simplify that, we're gonna use something called as name tuple, and we're gonna discuss what a name tuple is. Okay. So we have something called as name tuple.
Tuple.
So we're gonna
First we
import
have
this.
to import name
Yeah, we're
tuples.
gonna import the name tuple. So we're gonna get from collections import name tuple, and then so let's name it something, this thing, because VEC. Yeah, and
We have to make a class.
let's just make a named tuple, and you write a name tuple like this, and then you tell what is the name of the tuple is. We're gonna name it anything, vector, because it doesn't matter much. 2D. Okay, it will show on the screen. So yeah, maybe you can name it this. Okay, vector 2D, and then it has two field, x and
Why?
y. Okay, and we want this. This is, we can use this as a name tuple, but we want to have this as a class so that we can do the addition and subtraction. So we're gonna name is vec 2D, and then we pass this.
Daddy, but it says vector 2D over there.
That's the name we want to give.
Oh.
That's the name we want to use.
And then
This one is just the name it will show on the screen when we print it. Okay.
okay.
So now we got this vec 2D, and this will have a function called add, and this is the add function, and it will have self and other, right?
Other.
We're going to talk self and other. I'm going to discuss that in detail how it works. So after that, what we do, we'll return a new vector 2D, vec 2D,
See?
and then
Do X.
we can do pass x and y as it is. So if we want to, we can do self dot x plus other dot y comma self dot y plus other dot y.
What, you did y 3 times?
No, we just did the same thing which we normally do with this vector. Okay, let's just to see if this works.
Wait.
If this works, print.
Is it supposed to be self plus x?
Oops. Oh yeah,
Yeah,
you are right. You want to do x. You want to do x. Right. You are right. Okay. So this is the correct one. So x together and then y together. And the first parameter for the constructor is x1, and the other one is y1. So how do we create a vector? Let's say we want to create a vector A. We'll just say vec 2D, the name of the class, and then we pass x and y value. So let's say the x value is 2 and then minus 1. And then we made another vector which is gonna be B, and let's say this is vec 2D, and this is gonna be equal to
3.
Yeah, minus 4 comma
3.
So what the addition should be? A plus. Now we should be able to do A plus B, and when we do A plus B, what it will do? It will call this add function, which will return us a new vector. Okay.
Okay, so now we can just peacefully do A plus B.
Yeah, and now we'll check if this work or whether it is correctly work or not. So we see that we are printing the x is equal to minus 2. So 2 minus 4 is minus 2. Minus 1 and 3 is 2. So it is working as expected. So let's stop it. And now the other operation we want to support is gonna be the multiply.
How do we do that?
So the multiply is also similar. We just have a new variable called. We need to make a function called mul. Okay, and then we will return the new vector. So self is the current one, which is gonna be a vector. The other will be a number. Okay. So what we'll do is we'll do vec2 and we'll multiply with the other, and we multiply with the other. Okay. Right. So let's just test this out. In this case, B should be a number. Let's call it 0.5. So if we multiply with 0.5, what will happen?
Oh, it will decrease.
It will decrease, but how much? This will become 2
Half.
into 1, Half of 2 is
2,
1.
1.
And the minus is minus half.
Half.
So let's see what we get. We get 1.0 and minus half.
Half.
So we are getting the correct values. So you understand what we did. So basically namedtuple allowed us to create a new type. Now we don't have to use 0 and 1. We can use x and y. But it's the same. It's just that instead of using 0, 1, you can use still 0, 1 if you want to. But it's better to use x and y. Also, we are allowed to create the vector with the name tuple. We can, whatever name we give, we can use the function like this to create the object. Okay, the same way we were doing earlier. And then, but instead of name tuple, we said we want to create a class so that we have two new function, add and multiply in this one, right? Okay, so we got this. Now we can clean up all our code and use vec2d. So where else? We'll start with using a vec2d for this, and this. So all of them become vec2d. And now we come here, we need to do velocity plus. So now velocity is gonna be velocity plus acceleration, right? So we can write like this. This is gonna all remove. So accelerate elapsed time into elapsed time, and this is gonna be the velocity plus. Okay.
Peaceful mind, don't need to do 0, 1.
And displacement vector is gonna be equal to velocity plus so velocity into time.
You don't need 0 anymore.
Velocity into less time, right? Okay. And the position is gonna be equal to old position plus displacement vector.
And we don't need all this blah blah stuff.
So now we have very nice looking 3 simple equation, and let's try if our things still work properly.
Yay.
And it works perfectly fine.
Yay.
So this is much more cleaner, right?
Yeah.
Now this is much more cleaner. So now what should we do next? Let's now think about your favorite problem, that why the ball is going outside. It should bounce back.
Yeah, that's not supposed to happen. No, yeah, it's supposed to bounce back.
So now we have to come back to our maths again. So we have to do the maths again.
Maybe you do it by...
Yeah, so let's do the math
again.
So the first problem is that, so you have this ball which is coming up to down, and it's coming down. Now it could happen the ball is like this.
Yeah.
It can also happen the ball is like this in the next frame.
Yeah.
Right? It crossed a little bit.
Yeah.
So we cannot detect the ball, like this was the first frame and this was the second frame. Now, because, so you see the ball has crossed the line, right?
Yeah.
So we cannot detect, right, that it is exactly at this point, because either it is like this or it becomes like this. So we cannot accurately calculate the collision. But what our goal is that if there is any portion of it like this inside it, then it is a collision. And as long as we make sure that this thing is very, very small, we'll never notice.
Yeah.
We will never
notice.
So as long as our time duration between two frames is very, very small, then this also will be very, very small. Because see, if this is only 20 millisecond, it would have moved very less, right?
Yeah.
From here to here. But if it was 2 seconds, maybe it would just crossed everywhere and it went here from the previous frame to this frame, right? Yeah, if it was like here earlier and this becomes, it will become probably here if this distance is like 2 seconds or 1 second, right? So the smaller the time, the better the less the intersection will be, right? Now, how do you know that the ball is near the boundary? How do you know that? I don't know. So let's think. This ball has a center, right?
Yeah.
Here. And what is this point is? This is your position, right?
Yeah, position point.
This is your position. And what does points on this line will look like? What will this point will be? Let's say if this was the screen, what was this point will look like? This was 0,
That's
0.
0, 500.
Yeah, 0, 500, right?
That's 1000.
And then this was 1000,
500.
500. So what you can learn from this, that all the point below this will have, what does it look like?
Greater this.
Which will be greater? So if point was here, then what should it be like? It will be greater, like the y will be more than 500. The y will be more than 500, right? So what you know is that this all area,
Yeah.
y is greater than 500.
Oh, so if y greater than 500,
For this position, right? That's
Yeah.
what we are looking for, no?
then
We have a collision.
then we
No,
have
but
the
that's not simple. That will for the point.
Yeah.
That will be for the
point
point. We want to go for the boundary. So we need to add the radius also.
plus
So we need to
radius.
plus the radius. Okay. So if the position y component plus the radius is more than, is more than, yeah, it's going down, right? It's more than 500. That means you have a collision, right? Okay, makes sense.
Yeah, makes sense.
Now what will do when the collision happen?
Reverse.
We want to.
Reverse.
So let's try to do the reverse. Okay, we're gonna try to do the.
But it's supposed to bounce like this, not
So
like this.
let's see. So we first of all we want to check that the collision is working or not, and
Yeah.
then we'll try to do the
I hope
reversing.
it stops.
Yeah, we'll see what happens. Okay, so we're gonna try this out. So what
can
you
do
suggest
it.
is that we want to reverse. Now
You
we'll
can do it above our
we'll do here, right?
Yeah,
we'll do
right
here.
there.
We'll do right here. So if position
Daddy.
dot y, right?
This is not JavaScript. You don't need parentheses.
Okay, I forget this is not JavaScript. So if position dot y
Y.
plus, what's our radius? 25. Let's put this as a variable also. Yeah, we'll have to put a radius variable. We're gonna make a radius variable. Radius. What is the spelling of radius? I forgot. Okay, so 25 radius. So we're gonna make the radius.
That's radios.
And then this is gonna be radius. Okay, so if this plus this is greater than, we're just gonna make a, so that it evaluate this first board mass, right?
Oh,
And this is 500, right? Again, the height of the screen. So probably we should make this as a variable somewhere, but this is more than 500. Then what we want to do? You suggested that we'll change the velocity. We change the velocity direction, right?
velocity equals.
Velocity is equal to -1. That will change the. We'll reverse the vector altogether, right? We'll reverse
No, keep on going on like this.
We'll see what happens after. Okay. So let's play this around and see what happens. Oh.
What?
Yeah, we kind of did a one thing wrong. We need to make it little outside now. Okay, we have to throw it little outside. Okay, because it's already sticking to the boundary, so that is why it was happening. Bad thing. Okay, so we want to make this little bit outside, right? 200, and let's see what happens. Where am? Oh, still I'm outside. Make this 200.
Oh, please.
What?
That's good.
Why am I? Oh, this is not the one. We need to make this as 200. What were we doing with the velocity?
It was 100.
So velocity has to go up, which will be minus y, na?
Yeah.
Minus 100, right? Minus 200, and the x direction will be, let's call it 100. Okay. Yeah. Let's try. Oh,
Wait.
still why are we there?
Position maybe?
Hey, we were doing the wrong one.
You still. That's
Silly
what I was
Arya.
wondering.
Silly Arya, we are doing the wrong one.
I'm not silly. I was wondering why you were doing it.
So it is the plus digits, right? 1000. Okay, whatever. We don't check that.
Fine. Wait. Then go move it up. Why is it at 500?
400. Okay. Yeah. Now we went finally fine direction, and then we're gonna go there.
Yeah.
Oh.
It still bounced.
But there is a problem.
Like, no, I don't like bounce.
No, it bounced. But have you ever seen the ball bouncing back? It should bounce forward.
Oh.
It should bounce.
What
So if the ball bounces here, it should bounce forward, not backwards. So how do you solve this problem?
Why is it moving backward?
How do you solve this problem? What is the problem?
We need to buy half.
No, I think the issue is that Arya, that it only need to negative. We want to only reverse the component in y direction only, because the x component is still the same. So that it is moving forward, so it should keep moving forward with the same speed. It should keep moving forward with the same speed. But the y direction speed is reversing every time you are bouncing on the floor. Okay. So now what we need to do is we need to multiply with a
Position, acceleration.
Yeah, we need to kind of do both the vectors. So again, now this time we don't have any way. We're just gonna do y, and we need to make another vector, vec 2d, and the x direction is still the same. X direction is still the same. So we just want to write velocity, and the x direction is still the same. Dot x. We're gonna write dot x. Okay. Dot y. Okay. So let's save it and let's see what happens now.
Please work.
And now it is working.
Yeah.
Fine.
And now?
So now the only problem we
We
have.
have to do it on all sides.
Do you want to do it on all side? Okay. So let's solve it on the all side first of all. Okay. So let's go back to a paper.
Okay.
So now we did on this side. Let's say what we do. How do we do on this side? What does that mean?
That means
This side means if you are outside this, that means that your x is more than
1,000.
Yeah, x is more than 1000. So again now you need to make sure that your ball, if it's here, then if its plus radius is more than this,
Yeah.
then you are outside the
Screen.
wall. Outside the wall. Okay.
And let's do it on the up or down. So up is greater than 0.
Up also. Let's not worry about the up. Okay.
Yeah.
Let's not worry
It
about
doesn't
the
go
up.
higher than
Yeah, it will come back. It will come back because of the gravity.
Oh yeah.
It will come back. So let's not worry about it.
Yeah, and this is
This
greater
one is-
than 0.
This is gonna be. It should be more than 0.
No.
The x should be more than
0.
0. So these are the two things.
And this one is
We will ignore that because
yeah,
it will come
whatever.
back. It will
Yeah.
come back. So let's try to do that. So we need to add 2 more, right? So one was that if the x plus radius is greater than 1000.
1,000.
So in this scenario, what we want to do? We want the y to be as it is. Only the x direction need to be reversed. Okay? So the x direction has to be reversed. Now similarly, if it is
0.
less than, it's more, it is goes less than 0.
We'll do positive, I think.
Huh?
We'll do positive for
Yeah,
0.
Okay, so this is fine.
What? Change it to 0.
Yeah, but here actually we want to do minus. Okay? So instead of positive, we want to
Yeah,
do
that's what I was wondering.
minus, right? So both of them, not minus, right, we want to do minus, okay? So minus.
Greater than 0.
It should be less than 0. If it's less than 0, then again we want to do the x, we want to switch it, okay? So let's just try out if we got all our things working fine and we get to know that. Okay. Okay, the ball is bouncing.
Dun-dun.
Okay, so it bounced nicely. It is bouncing nicely.
Wow.
Wow. Now what is the problem, Arya?
I don't know. I don't see any problem.
Well, reality is not like that. It will not never bounce forever.
Oh yeah.
It will never bounce.
Whatever.
It will not bounce forever.
We can do that in the next video.
We can do that in the next video.
Yeah.
You like to see the bouncing ball forever?
No.
Yeah. So let's enjoy the bouncing ball forever.
No, that's
Okay.
not how games work.
So yeah. So
Yeah,
that's,
even if you're in pond. Yeah, no, that's how games work in pond.
so yeah. So we are done.